Okay, we're going to look at a couple of special factoring in this next video here. We're going to look at first factoring the greatest common factor out, looking at difference of squares, and then also perfect squared trinomial. So this is a YouTube video, so at any point in time, you can always pause it, and so let's get started. So we'll say first we're going to do factoring out the GCF, or the greatest common factor. So why we might want to do this is if we factor out the greatest common factor, what's going to be left is something that's smaller and usually a little bit easier to work with. And that's kind of one of the first things if you're solving quadratics or you're asked to factor, is to go ahead and see if there's a greatest common factor. If you can factor that out, whatever you factor out is just going to be along for the ride. You might do something with it at the very end of the problem, but after that it just kind of hangs out in the front for the most part. If you're solving, you might have one more step to do with it. Alright, so let's start with an example here, and we'll have 6x plus 18. And so what I'm looking for is I'm looking at the number 6 and I'm looking at the number 18. So I'm looking for common factors. 1 goes into both of them, 2 goes into both of them, 3 goes into both of them, 4 doesn't, 5 doesn't, but 6 does. And 6 is going to be the biggest one because it actually is the number 6 here. So if you get one of them to be one of here's the smallest number, if that happens, then that's definitely the greatest common factor. So the GCF here of 6x and 18 is just going to be the number 6. So what we're going to do is we're going to go ahead and factor that out. So what I'm going to do is we're going to factor the 6 out, and we got to figure out what goes inside these parentheses so I can get back to 6x plus 18. So it's kind of like a backwards distributive property. So I'm asking myself, 6 times what is 6x? Well, it should be x. 6 times x is 6x. We got the plus sign here, so we're going to go ahead and put the plus sign in there. And then I'm going to ask myself, 6 times what is 18? And you should get an answer of 3. Okay. And that's all we had to do. There may have been some other instructions, but this is just one of the skills you want. All right, let's try another example. One a little bit more, not too much more involved, but 3x squared minus 75. I also look at the variables, but the first example and this example only one of the terms has a variable, so we're going to only consider the numbers. 3 and 75. Well, 3/4 is 75 cents, so the 3 is going to be the greatest common factor. We can't be larger than 3. So I'm going to go ahead and say the greatest common factor of 3x squared and 75 is 3. And that's where we're going to go ahead and factor out. So we're going to go ahead and write 3, and then we're going to put parentheses in, and so we got to figure out what we need to put in the parentheses here. So if I use the distributive property, I get back to that. Well, 3 times x squared is 3x squared, and we'll go ahead and put that in there, x squared, put the minus sign in. 3 times, we already said it, 3/4 is 75 cents, so we should have a quarter there. Okay, and that's it. You might recognize this as x squared minus 25 is actually a difference of squares, so we will break that down a little bit further in just a minute. Okay, and we'll do one more example. 8x squared y minus 3xy plus 16xy squared. And so what I'll look at first is I'll look at the numbers 8, 3, and 1. 1 works for all of them. 2 does not go into 3. 3 does not go into 8. I can't go past 3 because 3 is one of the ones 3 is one of the numbers I want a factor of, so I can't go larger than 3. So 1 is the only common factor, and so we say that these numbers are called relatively prime because 1's the only number that goes into all three of these numbers. Next thing I look at is, okay, well, what about the variables? They all have an x. And then I look at, well, what's the highest power they all have in common? Well, 2 of them are just x to the first power, so that's what we got to stick with. That's what they have in common. They all have an x in common. Then I look at the y's. What's the highest power y they have all in common? Well, it's just y to the first. So our greatest common factor is they all have an x and they all have a y. Okay, and it's the same process. We're going to factor out an xy, and then we got to fill in the missing pieces. So I got to figure out what I need to put here so that when I distribute that xy through, I get back to my original expression here. So let's see here. If I want to multiply xy times something to get 8x squared y, I'm going to need the 8. And x squared means x times x, so I got 2 x's there, so I need 1 more x. When I distribute this x in here, right here, I got one of them, but I need one more until I get the x squared. So we got x. And we only needed 1 y for that first term, so the y on the outside is going to do just fine. The next term, let's see, we got the minus follows us along, and then we have 3xy. Well, that's what we want to make. I got xy, so xy times 3 will give me the 3xy, so we're good there. The last term, we got the plus sign there, and I need a 16, so we're going to write in a 16. I have 1x here, and we need 1x. I need 2 y's because I have a y squared on the 16xy squared, but I'm only including 1 y. So we're going to need a 16y here to finish that off. Okay. Let's go back to that screen. Okay. And that's all there is to it, you know, in terms of just factoring it. So let's move on to another topic, and this is factoring a difference of squares. So for us, this is going to happen all the time. We're going to see them all the time. And what's really important is being able to recognize a difference of squares, because our focus isn't going to be on factoring difference of squares. It's just a minor little step. Recognizing you have a difference of squares, and doing that is just one tiny little step in the process of a much larger problem. We might be solving something. We might be looking for some asymptotes or some places where we have undefined, well, not where we may be undefined or domain issues and that kind of jazz. So it's really important to recognize difference of squares. If we're just solely factoring, there are some situations where if we recognize it's a difference of squares, it's going to make our lives a lot easier, because we have another method of factoring that is in another video that would be quite difficult to do. Alright, so a squared minus b squared is factored in a minus b, a plus b. And if you don't believe me, you can take this right-hand side and FOIL it all out, and you get back to a squared minus b squared. So when we're dealing with polynomials and we're asked to factor or solve or look for domain, look for asymptotes, all those kinds of problems, you might be looking for difference of squares. We like to ask things with difference of squares because typically they're easy to factor. And so what we're kind of looking for is we're looking for 2 terms. So I'm going to go ahead and write in some stuff here, things to look for. 2 terms. And we're looking for subtraction because of the difference. And the 2 terms should be perfect squares, or the 2 terms are perfect squares. If I have those 3 things met, then it is a difference of squares. So let's do an example here. Okay, so examples of perfect squares. Alright, so here's a big long list. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196. Isn't this exciting? And 225. I don't know if 256 is one. Let me go check on that one. 256 is okay. Sorry about that. Okay, so there's the first big batch of perfect squares. So I would be looking for these numbers. Typically, you're probably going to see everything maybe, 144 and below, maybe 169. So if I'm looking for these numbers, and if I see these two numbers, and there's two terms, I'm asked to factor some of those other instructions that you'll find further along in college algebra. I would think maybe it's the difference of squares. Okay. And the nice thing is there's infinitely many of these things. So moving on, we will go ahead and rewrite the difference of square formula, just so it's up on the screen for our reference. And our instructions here for some examples is to factor, and I'm going to factor x squared minus 4. So I see two terms. X squared is a perfect square. 4 is a perfect square because it's 2 squared. So we have x minus 2 quantity squared. And that's going to factor into x minus 2, x plus 2. And so I have a base here of x, and I have a base here of 2. So that's kind of like my a and my b. So once I've figured out who my a and my b is, I can just use my difference of square formula to go ahead and finish that off. And we'll do a little green here, and we'll ask you to factor 16x squared minus 25y squared. So you can always pause the video and maybe, and try it on your own. Again, I see two terms. I see subtraction in the middle. 16 is a perfect square, x squared is a perfect square, 25 is a perfect square, and y squared is a perfect square. So what we can do is we can write 16 x squared is 4x squared, and 25 y squared is 5y quantity squared. And then again, here's my a, the 4x, here's my b, the 5y, and that's going to factor into 4x minus 5y. And 4x plus 5y. Okay. All right, and if we look at another example. All right, so 3x squared minus 75, we're again asked to factor. 3 is not a perfect square. X squared is a perfect square, and 75 is not a perfect square. I see two terms, and I see subtraction. So I'm thinking difference of squares, but 3 and 75 are kind of making this not work. However, one of the first things you always want to do is factor out the greatest common factor. And we actually did this as one of the beginning examples. And we saw that the greatest common factor was a 3. So we're going to factor out a 3, and oh look, it's a difference of squares. So it's going to factor into x squared minus, well, I'll let you look at it, and I'll narrate in just a second. Okay, so the 3 comes out. We have x squared minus 5 squared, just to kind of write it in that form, the a squared minus b squared. Remember I said the greatest common factor a lot of times is just along for the ride, and you don't do anything with it at the end here. See that 3, once we factored it, it's just along for the ride. It just kind of sits pretty at your answer at the end. Sometimes you might do something with it if you're solving or something like that. Okay, let's go ahead and do a little more. So we'll get a little bit more fancy here. X to the 4th minus 16, our instructions are again to factor. Now the x to the 4th isn't a perfect square, but it is the same thing as x squared squared. Okay, so when I raise an exponent to an exponent, I'm going to multiply them. So 2 times 2 is 4. 16 is 4 squared. So this is going to factor into x minus 4, x plus 4. I said that wrong. It's going to factor into x squared minus 4 and x squared plus 4. Okay, now these are one of those sneaky problems where they're probably going to tell you to factor completely, and that's usually expected when you're solving or looking for the domain issues or looking for asymptotes. So they want you to factor completely. They may not say it, but it's kind of understood what you want to do. So we got to do a little more factoring. They're sneaky here. X squared minus 4 is a perfect square. I'm sorry, not a perfect square. It's a difference of squares. So it factors into x minus 2 and x plus 2. And x squared plus 4 is a sum of squares, and that's not going to factor. It factors over the complex numbers, but we're keeping it real for here, this part here. And I mentioned there's no sum of squares formula over the reals, or the real numbers. Okay, and just for fun, I'll show you an example here. X squared plus 25 does factor over the real numbers. Remember we said I squared is negative 1. So x squared plus 25 doesn't factor over the real numbers, but it does factor over the complex numbers. Okay. So let's look at x minus 5i and x plus 5i. That's going to equal to x squared minus 5i x plus 5ix minus 25i squared. So that's FOILing it out. Notice that the 5ix's are going to cancel. You got a negative sign here. And you got an I squared here. So I squared is negative 1, and that negative 1 is going to get rid of this negative here, so you're going to be left with x squared plus 25. Okay. Now in we'll mention I squared is negative 1. Now in section, I think it's 5-6, last section in chapter 5 we will do stuff where we construct polynomials with certain roots and that kind of stuff. So you will see it, but it's one of the few sections we'll deal with complex numbers. Okay, so again, these things are meant to make factoring much easier. Greatest common factor, difference of squares, and then the last thing we're going to look at is called perfect square trinomials. I think your book might call it like, I forget what they call it, trinomial squares or something like that. This is another one that we often like to use along with difference of squares and greatest common factor. It's very easy to factor, makes it a quick problem. We're going to be testing you or testing you on things that require this, but we're not specifically asking you to, as a problem, is to factor just to factor. It's just one step. And why we pick these problems is they're usually easier to do than requiring you to have to do the quadratic formula to find where you have problems with your domain or asymptotes and that kind of stuff. All right. So we have two forms. We have the positive version, which is a plus b quantity squared. And you got to be real careful here. A plus b quantity squared means a plus b times a plus b. It doesn't mean a squared plus b squared. Doesn't work. Remember, we just said we don't have a sum of squares formula. The negative version is very similar. If we FOIL this out, this is what it ends up looking like: a squared plus 2ab plus b squared. The negative version is identical, except for where you have the positive 2ab, you'll have a negative 2ab. Okay. So our goal, again, kind of like recognition of difference of squares, is recognition of perfect square trinomials. If you can see it, it's a perfect square trinomial, you're making your life a lot easier. So we'll mention a couple things to look for. Maybe we can speed this up a little bit and then I'll narrate over it. Let's see. So, things to look for: 3 terms, two perfect squares, and then the linear term is twice the product of the two bases. So, oops, let's go back. Okay, so let me kind of mention what that means. So 3 terms, 1, 2, 3 terms, 1, 2, 3 for your trinomial. Perfect squares, usually it's going to be the first and the last are perfect squares, and then the linear term, you know, it'll just have an x, or it might have an xy, so there's nothing square on it, is going to be twice the product of the two bases. And the bases are going to be your A and your B. Okay. Alright, so let's go ahead and try and factor x squared plus 4x plus 4. It's a trinomial. There's 3 terms. I notice that x squared is a perfect square, and I also notice that 4 is a perfect square. The basis for the x squared is x, the base for the 4 is 2, so we're going to check what is twice the product of those two bases. So x squared plus 4x plus 2 squared, just rewriting it. You don't have to do it this way, but I'm just being extra careful. Okay? So your two bases are x and 2. If I take twice that, I get 4x, and that is exactly the linear term. That tells us it's a perfect square trinomial. And get x plus 2 quantity squared. Okay. Alright, let's try another one. 4x squared minus 25, oh, sorry, I did it out of order here. 4x squared minus 20xy plus 25y squared. 3 terms. 4x squared is a perfect square. 25y squared is a perfect square. Okay, so I'm just going to rewrite it just so we can see the bases. Okay, so our bases are 2x and 5y. So I'm going to take the product of those two and then take twice that. If it's 20xy, then it's a perfect square trinomial. So 2x times 5y is indeed 20xy. Okay, so that matches. So this is going to factor into 2x minus 5y quantity squared. Just following a formula, you can FOIL it out, and if you don't believe me, it works out just fine. This is the minus version because we had the subtraction. Alright, let's do one more. So we will do 12, let's see, I'm going with big numbers. 121x squared minus 154xy plus 49y squared. And we'll go ahead and rewrite that with our bases. So our bases are 11x and 7y. There's 3 terms, and we got 2 perfect squares. We should be suspicious that is a perfect square trinomial. So we're going to take twice 11x times 7y. If that matches 154, which in fact it does, if you don't believe me, you can punch it into your calculator. Just don't punch too hard, and you will get 154. So it says it's a perfect square trinomial, and we factor into 11x plus 7, I'm sorry, not plus, minus 7y quantity squared. Okay. I also show you the AC method. That video is floating around also. This is not a good problem to do by the AC method, which means we would be multiplying 129 times 49, and that's like a big number, and then we'd be looking for factors of that big number that add up to or have a difference of 154. So it wouldn't be pretty. Okay.